Yesterday, we found out that there's actually a different way to measure an angle. You could do it in degrees or you could do it in radians, right? All right. So let's say, and I give you this circle, right? That I'm going to try to find the arc length. The radius is 5 and the angle is pi over 6, which is in radians. The only formula you have to find that length of an arc is this one right here from day 2. But I can't use it. It's worthless right now. Why is it worthless? What's got to get plugged in here? Degrees has to get plugged in there. I can't plug in pi over 6. So today what I'm going to do is I'm going to give you another formula for length of an arc, but it can only be used if your angle's in radians now. All right, so by the end of today's class, you will have 2 formulas to find length of an arc. One using degree, one using radians. Okay, so that's today's topic. So what is that formula? You know what? I don't even care. I'm so confident. Don't care. Yeah, exactly. So what is that formula? First of all, I don't like it starting like that. So can you get rid of that? I made a decision this morning. I'm going to teach it a little differently than in years past. So if your angle is in radians and you want to find the arc length, here's this formula. It's pretty small. S, that's a lowercase cursive s for some of you. I had a couple people ask me, what is that? It's a letter. It's cursive, sorry. Equals, I'm going to introduce this symbol today, a circle with the little equator going through it. Theta, it's a Greek symbol, Greek letter in the alphabet, times r. S equals theta r. Some kids like to remember it by saying SOR. Oh, okay, I get it, SOR. You just say it, yep. What's each piece mean, real quick? S, that's your arc length. No idea why they call it S, sorry. That's my arc length. Theta, that's your angle measure, but it has to be in radians. If it's in degrees, I got another formula for you from day 2. And then wild guess what R is going to mean? Radius length. All right. So there's my formula to find arc length if my angle happens to be in radians instead of degrees. All right, you ready? Let's do this. First one, find the arc length S. I automatically go to the central angle and look what it is. Pi over 3 radians. So I cannot, well, I guess I could convert it over and use the day 2 formula, but now I'm going to have to use S equals theta r. That's the formula I use to find arc length when the angle is given in radians. So here we go. S equals, what's my theta here? My angle measure. Woo, 8 angle measure. Pi over 3. And I don't need to ask this because it's sitting right there. Times 5. Please read the directions. I don't want this in terms of pi. Let's round here, nearest hundredth. There go the covers off. When you're ready, 13, nearest hundredth. 5.24. Good work. All right, same thing. Number 2, 10 pi over 9. I want the arc length, but the angle's in radians. So I have to use S equals theta r. I keep saying you have to use it. You don't. Hopefully you guys realize that if you don't want to memorize 2 formulas and just memorize the one I gave you on day 2, you're going to have to take 10 pi over 9 off to the side and turn it into degrees. And then you can use the day 2 formula. All right, so but it's your call. I'm just showing a different way to find arc length if it happens to be in radians. So S equals, what is my angle measurement here? Woo, 28 angle measure. Thanks. Times 27. 23, nearest hundredth.
94.25.
Yep. Bless you. All right, we good? All right, a little different way to use it now. Before we start numbers 3 and 4, I just want to make a note here. Take a look. The 8 pi is represented the arc length. That's the arc length, not the measure. All right. 15 pi over 7 and number 4, that's how long the arc is. I just left it in terms of pi instead of writing out the full decimal. And I want you to find the angle in radians and in degrees. Radians and degrees. Does it matter which one we find first? No. All right, I'm going to find it in radians first, but hey, whoa, before we get ahead of me. All right, before you keep doing the notes ahead of me, I just want it, if we decided to say, you know what, let's be crazy and find it in degrees first, I would go back to the formula from day 2. Arc length equals, what would I put in place here? That's what I'm trying to find. X times pi d 32. And we'd solve it for X, just like we did on homework a couple nights ago. That's if we were getting nuts and we wanted to go degrees first, but I'm going to do it in radians, so I wouldn't use this formula. I would use S equals theta R. Just remember, though, when we solve for the angle, what type of units will it be in? Radians, right? It will be in radians at the end. So what is the arc length again? So I can plug that in for S. 6 arc length, 8 pi equals theta, what we're solving for. R is times 16. What do I need to do there to get theta by itself? 18. Good job. 9. What do I need to do on both sides to get theta by itself?
Divide by 16.
Divide by 16. And remind me one more time, this answer will be in what type of units? Radians. And how do we leave radians in here? Terms of pi. So I don't need that long decimal written out. I want this in terms of pi, please, because it's radians. So all you guys need to do is reduce 8 over 16 for me. So what's that answer in radians? 22?
1/2 pi.
Yep. Pi, 1 pi over 2, or just pi over 2 if you want to get rid of the 1. So pi over 2 radians is the angle. Now, how am I going to do this in degrees now? Smarter, not harder. Work smarter, not harder. I don't want to have to, that long formula I just had up here, solve for x. I don't need to do that. How can I just go from pi over 2 to degrees now? We did this yesterday, right? I can take a radian and put it into degrees. Take pi over 2, multiply it by, what's the conversion? Oh, 13. There you go, on fire, 180 over pi. This is not cross multiplication. Just numerator, numerator, denominator, denominator. Pi's cancel. And how many degrees are in this angle? I know it's pi over 2 radians. How many degrees? 12. 360? How'd you get 360?
Oh, 90.
90. There you go. What happened there? You good?
Yeah.
Okay. Regroup. Happens to the great ones too. Don't worry. Believe it or not, I do make a mistake on a yearly basis. It happens. We all good? Now, would I have gotten 90 if I solved for x in that formula I'd written out? Yeah, you would have. It would have taken a little longer, but we could have. All right, next one. Let's do radians again. What's my arc length to plug in for S? 7. 15 pi over 7 equals theta times r, 5. Again, how do I get the theta by itself? 16.
Divide by 5.
Divide by 5. Divide by 5. My answer's in radians, right? You better have a pi in it. So 15 over 7. I go to my I'm not going to do it for you, but get up. I got to put 15 over 7 on top. And then on the bottom, divided by 5. But notice no pi in there because I'm leaving my answer in terms of pi. I just got to have my calculator reduce that. $22. What are we in radians?
3 pi 7 over 7.
Yeah, thank you. And now let's put it in degrees. You're going to get a decimal here. Let's round to the nearest tenth. All right, let's round to the nearest tenth. Nearest tenth, how many degrees in there? 9.
77.
Tenth? Okay, anything? Do we see that there's two different formulas? One's for both of them are to find the length of an arc. It's just one's got to be in radians and one's got to be in degrees. You okay? So Reed doesn't get nervous. We're just doing a little arc length together. All right, next one is just a lame attempt to try to relate this to the good old real world. Pendulum of a clock. Well, let's first stop there and talk about real life. Pendulum, we're all good. Some people last period didn't know, and that was fine. Pendulum swings from the clock back and forth. Good? We all good here, everybody? Yeah, this comes up every year. It drives me insane. Here's the question. What would never be on the wall in the Carlino house? This bad boy. Okay? And that's not even like, it gets worse too. The pirate, cactus with the sun hanging down, the bear with the lion with the tail. Come on now. And the bee, oh, God. No. And it's like, what's worse is, hopefully it'll come up. Oh, sold out! Please. Get a grip. Who is selling that out? Oh, the monkey with the banana. Yep. No way. There's no way. Didn't even take this long. I'm just trying to point out the price of these. And now that they're sold out, makes it even ridiculous. There you go, a little horse with the horseshoe. This definitely can't be sold out. Look at this thing. Everybody should see that thing? And of course it is. Of course. Yep. What's not sold out here? Oh, we did this one last period. I don't think the barn is sold out. $70. $70 for this item. You might just throw it in a fire pit. $70. Here you go. Right in the fire pit. Yeah. So I guess if anybody wants it, that's one that's not sold out. It's the horse there. What? But pendulum. We're all good now? Moving back and forth? All right, good. All right. And you're welcome for the beautiful diagram of the pendulum. All right. So as it moves back, as it swings, it's going to make an angle of 2.5 radians. All right. So however big you want to make it, here's the pendulum starts. It swings back and forth. It's going to make an angle of 2.5 radians right there. That's what the pendulum makes. Angle of 2.5 radians. And it travels along an arc of 50 centimeters. So that's going to be my arc length, 50 centimeters. Here's where you might get tripped up. I don't have the vocabulary term we have been using all today or all through the entire unit. I'm just asking what's the length of the pendulum. What vocabulary term could I substitute in there? Find the? Okay, just make sure we're all clear here. The radius is AKA the pendulum. And 50 is the what again? So automatically, oh, I know arc length. I'm going between two formulas. The one from day 2 and SOAR today. But 2.5 is what units? Radian. So, and if you want to convert it, you can, but you can automatically use S equals theta R. $50 equals 2.5 R. Just making sure we're paying attention here. How do I get the 250 out of there? 5, how do I get the 250 out? Or the 2.5?
Divide.
Yep. And R ends up being, what was this one? 20? 20? $70 for that. 7. Hopefully I'm not offended. Every year I gotta always think about, am I offending anybody? Like somebody actually has this up in their bedroom and it's sentimental to them, and I'm just absolutely destroying it up here. Okay. I got that for my birthday. All right, hopefully I had the return receipt. All right, moving on. Central angle, now I have a circle, central angle of 3.5 radians and an arc length of 24.5. Find the diameter. All right, real quick visual, right? Central angle. We know a central angle starts at the center and goes off to each side or each point on the circle. That forms an angle of 3.5 radians, and it goes to an arc length of 24.5. Diameter? Am I going to get that right away? No, I can get what, though? Radius length. Yes, I can get radius. So I go back to S equals theta R. S is, what do we got for S? 24.5. Theta is 3.5. And then go ahead, divide both sides by 3.5. Radius, and I get nervous here because this is usually where we just stop on a quiz and move on to the next problem. What's the radius length? 11?
7.
7. And how you getting to the diameter? Because I'm not done yet. 19. How do I get to the diameter? Yep. $14 centimeters. Good. Real quick change. Can you make? What a great day, right? Pendulums and the Promethean man. That's so good, your misery. So we had this for arc length already, if it's in degrees, but today, make sure you change it. S equals theta R if it's in radians. All right, one more problem here. Jeff Star?
Yeah.
You didn't?
That was the first one.
Oh, you didn't have curtains. Sorry. That was great. That was a great moment.
No one was gonna.
All right, so here we go. We're going to calculate the length of minor arc. That's huge to know, that minor arc, because there's two arcs ABs up here. So which one do you want me to find? The minor arc one. And we are going to do it in both radians and degrees. Okay, we're going to do this. I just want to prove to you that it doesn't matter the formula, answer stays the same. So what's my angle in right now? What's my angle in right now? So let's use the degree formula first, all right? So the length is going to be equal to, here you go. This is our day 2 formula using degrees. Help me out. 21?
165
over
360
times pi times,
diameter.
which would be
4.8.
4.8. And let's see, it doesn't say leave it in terms of pi, so go ahead, nearest tenth of a meter right now. Nearest tenth of a meter. I can just make sure you use your pi button. Uh, 28.
6.9.
6.9. Good work, Tyler. So there's the length of minor arc AB. I want to use the other formula now. S equals theta R, but hey, we understand I can't plug in 165 for theta. Only radians go into that. So here we go, off to the side. Help me convert 165 into radians so I can plug it in for theta. Because you cannot plug 165 into this formula. It's in degrees. What do I multiply it by? 19?
Pi over 180.
Good job, pi over 180. We leave it in terms of pi. So somebody reduce that for me. 165 over 180. That reduces down to 10.
11 pi over 12.
Good, 11 pi over 12. Now let's go back to the formula. S equals 11 pi over 12, but now times 2.40, the radius. I don't need to convert that. That's just the radius. And magic will happen when you type this in your calculator. $6.9?
Yeah.
Okay. It doesn't matter what formula you use as long as you're in the right units. All right, so that was my point here today. Make sure you're in the right units. Can you flip it over? Look at question 2 from the homework. It's a little bit confusing, and I want to make sure you guys are good. So take a look at number 2, please. This is a multiple choice one. A circle has a radius of 12. Now, it has a radius of 12 for all the multiple choices. All right, it has a radius of 12 for all the multiple choices. So which of the following choices is the wrong information there? So for instance, number 1, you have a circle with a central angle of 120, a radius of 12. Would you get an arc length of 8 pi with those numbers, plugging into the correct formula? Number 2, now your central angle is 6 degrees, still a radius of 12. Will you get an arc length of 72 with that information in the proper formula? Same thing here, but I just want you guys to realize your radius remains 12 for all the choices. And you're looking for which one gives you the incorrect arc length here. Which one gives you the incorrect arc length based on the information? All good? Okay, start it up. You got plenty of time. Let's do this. Start off with Big Al, and he thinks A and B have the same radian measure. Correct or not?